what that means is that, and you can easily convince yourself of this, if you look at the generator, look at the generators of those things. What does it mean physically? It means that if you do a bunch of motions, you can't end up with this guy just flipped. If you flip one, you've got to flip another one. It means that this is an orientation, that the group of the cube is orientation preserving. It is a member, it is a subgroup of not S54, just S54, but A54, the alternating group. It is an even, they all have even numbers. Does that make sense? Similarly with the threes. There seems to be something, I can't twist this and end up with just this one corner moved. If I rotate one, I have to somehow rotate another. And so 5 years ago, I was working with Yuri Lin. And this, what does this show? This shows, I'm going to quickly go down to her result, and I'll let you look at G4 and G5, what I've called G4 and G5 by themselves, another time. She came up with this notion that, let's say, I'm not going to do this to nice Mr. Young's cube, but you all probably also know that if I twist this guy here, and I come along with a screwdriver, I can actually physically remove a cube from there, and that is a way perhaps that some others of you, rather than peeling off the labels, which is much easier, it's another way to solve the cube is to actually physically take it apart and put it together in correct fashion. And so let's say that I came on a cube, and it's lying there on the ground, it looks like this, and it's lying there on the ground, and there's a piece out. Well, does it matter which way I put it back in? Well, yes it does. And you can convince yourself that the fact that it is even, the fact that it is orientation preserving, what is easy to show, and it would take a few steps, which won't bother, is that if I put it in the wrong way, I have a cube which is unsolvable. I can get really, really close, but I'll get really close and I'll get all the way to the end, and there'll be one thing which is the wrong way. And if I put it in the right way, then it's solvable. And that's easy. And what Yuri proved was that she actually came up with a way of a completely mixed up cube of figuring out how to do it. And I'm going to show you that, very quickly show you that method. So think about how on earth, so you have this mixed up cube, everything everywhere, right? Oh, there's a little bit too much yellow together. I think I'll mix that up a little bit more. Okay, really, totally mixed up. And one of the faces is on the side. And how do I figure out what to do, how to do that? Well, here's what I do. I'm going to pretend that the six middle faces are, those are going to be where I'm going to end up, right? Orange on top, yellow on the side. And I'm going to take any piece, and I am going to figure out this piece, according to this is yellow on top and red on the side. So this piece, the correct position for this one is, since red's on the bottom, would be over here. Okay? This piece would take exactly one twist to get to its proper position. Each quarter twist is one. Okay? So this piece would take exactly one twist. Are there other ways to do that? Sure. Could I take more than one twist? Absolutely. One of the things that Yuri proved, and this is called a lemma in math is a little step on the way to a bigger step. She proved that if this takes only one step to get there, no matter how else I get there, that number of twists has to be odd. That you cannot, that it absolutely positively has to be an odd number. And then taking this corner, how many twists would it take to get this corner to its proper position, wherever that would be? Well, lots and lots of different ways to do it. Those people who know cubes. That number is either an even number or an odd number. And what she showed was, if I start with a whole cube, every time I do a move, I am doing an even, total even number of switches. Because I'm doing how many moves altogether? Well, there are, on this particular thing, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 21 faces, right? This one's not moving, so I'm doing 20 faces. I'm moving 20 of them one turn. So I am increasing it by an even number. So what she said is, let's say this particular piece is out. I'm doing this a little fast because we're just about out of time. If this little piece is out, if I take every other piece on the cube and figure out how many twists it would take to get to its proper position, and add them all up, I will either end up with an even number or an odd number. And then I look at this thing. If I put it in one way, it'll be even. If I put it in another way, it'll be odd. Whatever gets me to a total of an even number is the correct way. Because it's absolutely... So it had to do with this orientation preserving. And, by the way, how many moves